Yes, one of the very important concepts in kinematics is to know what is displacement. What is displacement? Displacement is the shortest path from the initial position to the final position. For example, you can imagine this situation. You are in your college and your college gets over by say 3 p.m. and you want to go to your home. So, you are going from your college to your home 3 p.m. and what are all the possibilities of reaching home from college? Typically, you will not go to your home directly from college, right? So, you will stop here, you will go to a small snacks bar and then you will go to your friend's house to drop him, and then you will just have a peep at the corner ground who is playing and all, and then finally you will reach your house. So, this is the actual path taken up by the child. Now, if you consider the straight line path from the initial position to the final position, this is what you call as the displacement. It is the shortest path from the initial position to the final position. It is a vector quantity. Why is it a vector quantity? Because the direction is also involved. Where is the direction involved? I said initial position to final position, which means that there is a direction and it is also the shortest path. So, clearly the shortest path can't be along any random direction. Thus, it is a vector quantity and its SI unit is meter. Now, many a times we need to represent this in the mathematical form. How do we do that? It is done in this form. It is given as final position minus initial position. For example, let us consider x axis here. This is the origin, and let us assume that the particle was located initially here and it went to the final position here. The x coordinate of the initial position is xi, the x coordinate of the final position is xf. So, the displacement which is represented by s is the final position minus initial position. But you should be very careful here, it is a vector. So, I should represent it with appropriate symbol. So, xf minus xi. So, this is how you represent the displacement. There are some important properties or say concepts or important points to be noted regarding displacement. What are those? First of all, displacement can be positive or it can be negative or it can be 0. Under what circumstances is it positive? Under what circumstances is it negative? Let us see. To do this one, I will consider this x axis. This is the origin and the particle is located here initially xi and xf. So, notice that the particle's displacement is given by s is equal to xf minus xi. You should keep that important equation in mind. Now, displacement is positive if xf is greater than xi, as in this example. So, do you notice that, for example, this is some 2 meters, this is 4 meters. What is the displacement here? S is equal to 4 minus 2, that is 4 minus 2 is equal to 2 and it is a positive quantity. Thus, the displacement is 2 and it is along positive x axis. Now, if I consider the second situation, for example, here the origin is here, the particle's journey began from this position and it ended here. Now, look at it, displacement is negative, isn't it? Because the final position is less, initial position is more. For example, this is 2 meters, this is 4 meters. So what is the displacement now? I should write it as 2 minus 4, it is minus 2, that is actually along negative x axis. Can the displacement be 0? Let us see. If xf is equal to xi, it can be 0. For instance, here the particle began its journey from this position. Now the particle begins the journey from this position, it goes along this path and it returns along this same straight line path. I am showing it below, but remember it is coming back along the same track. Where is it finally? It is where it started. Morning you start from your house, your home, and you end up at your home by say 4:30 p.m. What is your displacement? Displacement is 0 because xf is equal to xi. Remember, displacement is always equal to or less than the distance travelled. Magnitude of the displacement is less or equal to, magnitude of the displacement is less than or equal to the distance travelled. So, less than or equal to the distance travelled. And also displacement is path independent. What does it mean? I will take the same example. This is your college, say, and this is your home. You start from, say, in the morning, what do? You directly run from your home to your school or college. You are short of time and you are running. And evening, this is how you reach your home. But in both the cases, the path does not matter, the displacement is same, which means that it is independent of the path selected.